Patrick Cook here. So thanks for joining me in the first session of a series which I refer to as the Mandelbulb3D Gotcha series. Now, the point and the purpose of this particular series is to introduce you to some problems that the Mandelbulb3D fractal generator application has. I call them gotchas collectively, but we're talking about some bugs. We're talking about some inconsistencies, some idiosyncrasies, and even some crashes. So in this series, I want to be talking about the various gotchas of the Mandelbulb3D fractal generator. These videos are not rants. They're not even complaints. What these videos intend to do is to give you an idea of where some software issues exist, what they mean to your creative work, how to avoid them. Now, it's important to realize that the Mandelbulb3D application is a 2010 through 2015 vintage software application. It was the work of a collective group of Mandelbulb fractal enthusiasts. The original author or the head of the project, the open source project, was a fellow by the name of Jesse. I don't know his last name. I don't even think he had a last name in terms of the community. But this individual and a number of enthusiasts of the Mandelbulb fractal, as well as some software development capabilities, began working on this Mandelbulb3D fractal generator, way back in the 2010 through the 2015 era. At some point, Jesse decided to quit the project for whatever reason. Probably had other things to do, maybe a great job offer. I don't really know. But the software, the Mandelbulb3D software effectively went into oblivion at that point. It was not, and the source code was not available up online as open source at that time. At some point, the application was turned over to another individual who has since managed it. Now, I relate that little story because the Mandelbulb3D application is obviously not a commercial application. It is not going to get that many updates. All right. There have been some, and there's been some features that have been added to it, which are very valuable. But I'm not seeing a whole lot of updates. And in addition to that, I don't think we're going to be seeing these issues that I'm bringing up in this Mandelbulb3D Gotcha series. I don't think we're going to see those corrected. And the reason for that is, primarily, I believe, is that the owner of the software development environment has pretty much got the software development tools are behind a paywall. It could cost you as much as $3,000 just to get the software to be able to get into the Mandelbulb3D source code, modify it, and compile it. Now, anybody can look at the source code. Looking at the code is easy. Go up online. Matter of fact, I'll put a link up here on the screen for you. But now, compiling it so that it's a functional software application that can be redistributed, now that's a tough nut to crack. I've tried it. and I ran into this paywall, and I also ran into third-party, what they call libraries that are long gone. The point is that the chances of the Mandelbulb 3D applications gotchas being repaired are, I'm going to say, slim to none. Now, that's not necessarily bad news because the Mandelbulb 3D software is not a commercial application. There is no big corporation behind it to fix the gotchas and also to add features, all right? Because nobody's going to make any money on it. So why bother? Go off and do something and make another blender or something like that and go make a lot of money. The Mandelbulb 3D software is not a commercial application. There is not a commercial vendor behind it. It doesn't hold much promise at all to make money selling the application, and therefore it's probably not going to get repaired. That's not necessarily bad news, because the point I wanted to make is if you don't have a vendor behind an application, you can count on the gotchas, the problems, the bugs being there for a long time. And once you know that, you know where they are and you know how to avoid them. And that's what I want to try to convey in this series. All right, look, the Mandelbulb 3D application does not have any error logging internally. It does not have any error reporting back to a particular source. When an error happens, when a crash of the application happens, the only person who knows about that particular crash is the person who's sitting at the Mandelbulb 3D application at that time. I call him the creator. That's the person who sees the error, has a very good idea why it happened or that it happened and the consequences. They lose time, they get frustrated. But nobody else is going to see that. There is no error reporting and error logging. So, what do we do? What we do is we talk about the problems and the issues of the Mandelbulb the fractal generator application so that we understand where the gotchas, the bugs, the crashes are, and we can avoid them. Now, I want to start this series with a particularly annoying problem that has an impact on creativity. I guess we could call it a bug. It's more of an annoyance, and I'm gonna try to explain what this thing is, what the problem is, how to avoid it. Now, I call this first gotcha, I call it the far plane takeover. And that's what we're going to spend the rest of this session talking about. All right, let's turn our attention to the Mandelbulb software. Now I have the work environment set up right here. This is the main editor, often referred to as the main view. This is where you're going to arrange your formulas. This is your lighting, your formulas, your lighting, and some other capabilities. This is the main editor. Right over in here, this is the navigator. This is where you're going to be able to navigate through the scene. Down here is the animator, and I've got some keyframes left over. Let's get rid of those. This is the animator window. Now, all right. Now, first of all, a little bit of education as to what this far plane issue is. Now, just kind of take a look at the main editor here, and you see a Mandelbulb scene. Yes, those are Mandelbulbs, and these are the formulas that go into making that particular Mandelbulb. Oh, by the way, this is This is an M3P file, all right, that I've opened up, and this is from my Dazzle Mandelbulb 3D animation. So you see here that there are two formulas. You've got formula, no, I take that back. You've got three formulas. You got an amazing box in formula slot number 1. Formula slot number 2, this is a transform, which is called scaling. And in formula slot number 3, you've got an IDES formula. Now, this is not a training on formulas. I'm only trying to give you an idea that this scene here is a Mandelbulb scene, and it is made up of 3 formulas. Now, the far plane. The definition of the far plane, which is the topic of this particular gotcha session, you have one view. You are the view. This is your camera. You have one camera, all right? You, the view. You are the camera. There is no up, down, left, right cameras, no multiple cameras, one view. Now, in that one view, that one camera, you have a thing called a far plane. And that is where the Mandelbulb rendering software, all right, will not generate any graphics beyond the far plane. All right, so this is the far plane, whatever that might be, we'll call it 10, okay? So after all the graphics between you, the camera, and 10 will be rendered. Anything beyond that won't be rendered, okay? Let's call that a 10. If you make a far plane of 20, it's out here. So these graphics will be rendered, these will not be. A far plane of 100, all right, would go pretty far out there. Now, the point and the purpose of the far plane from a well, I guess we'll call it a computer resource standpoint, the point and the purpose is to limit the amount of graphics that have to be rendered by clipping all of those graphics out of the... Now, if we're not rendering all these graphics out here, well, that's less work that the computer has to do to render that scene, okay? That's benefit number 1. It cuts down the amount of work, effort, and time to render, as well as resources, CPU clocks, memory, RAM, that sort of thing, okay? From a creative standpoint, which is what we're interested in, the far plane will allow us to not have our background so busy that everything just becomes a whole mess of detail. We can actually creatively limit how much graphics are on the screen. Let me give you an example of that. I'm only concerned with our creative aspects. I don't care about the computer horsepower. You can throw all the horsepower you want at the Mandelbulb 3D. Creatively is what we're interested in. Take a look at our scene. All right, so that scene, now you can see here some dark areas here. All right, these dark areas are basically where there is no graphic or there is no rendering of a graphic. All right, now the far plane. The far plane is right here over on the navigator. Now, you see here that the far plane is currently 448.3. We don't know what those units mean. We don't know. We don't know if it's inches, centimeters, miles, we don't know. And it doesn't matter. What matters to us is the relative number. And basically it means this, that a low far plane value, right in here, a low value is going to be where the graphics between you and the far plane are rendered, the rest are not. Let's call that a far plane of 10, a low number. A far plane of 100 would be further out, it's a higher number. So the rule of thumb is with the far plane value that the lower the number, the closer the far plane is to you, the view, or you are the camera. All right. So in this particular case, I've got a far plane of 448.3. Now, take a look right here. All right, this is our navigator. It's a low resolution rendering of the main view. And the idea is so that you can navigate through the scene and this view will update very quickly. All right, let's keep an eye on this. So what I'm going to do is I'm going to change that far plane to, I'm going to change it to 50. And now, what I'm going to do is I'm going to push this back to the main. I'm going to view to main, and I'm going to recalculate it. Now, I had a 448, now I have a 50, and you see here I got a lot more black in here, because what I've done is I've moved my far plane from here to here. So there is less objects that are being rendered in the scene. As you can tell by there's more black space. I'm going to put this back to 448, push that back to main, calculate. So now I've got more objects in the scene. That's what the far plane does. Now, I think you can pretty much see at this point that the far plane can be very useful for creative purposes. Let's do it again, but this time let's do a far plane of, I don't know, 5. All right, push that back to main, calculate. You see? Now, I can do some really creative things with this far plane. It's a very, very powerful tool for creative use. Now, let's do something crazy. I had 448 there. Let's put 5,000. Is that 5 or 50? That's 5,000 right there. Push that back to main. Now watch this. Look at all the stuff that is now in the field of view. Okay? Now that's too busy. For me, that is too busy. That's not the scene. That's not the story that I want to tell. I don't want the viewer to be loaded down with all of those, all of that graphics. So 5,000 is too much. 5 that we had before is too little. What does that mean to anybody? All right, but look, let's do 100. Let's try 100. Back to main, calculate. That's very interesting. Now look at that. Now we have faint indications of hints of stuff in the background. Now we've given our scene some depth. We don't allow the viewer to see all the way down, but yet we're not blinding them with only what's right up front. Okay, so we gave the scene depth. Now I think I've made the point that the far plane can be a very good creative tool. Now let's get to the problem. I know you were waiting for this. Let's get to the problem. The problem is that under certain circumstances, Mandelbulb will change the far plane for you. And you don't want that. Especially if you're trying to be creative with the Mandelbulb. You don't want the Mandelbulb to be changing the far plane for you, but it does. It's important for you to understand under what circumstances that far plane value is changed and what you could do about it. All right, now let's demonstrate how the Mandelbulb will change the formula for you. Let's go back to 448 since that was pretty good. All right, not bad. All right, now there's some background here. Okay, the objects in the background are starting to come into view. The scene's got some pretty good depth to it. All right, all right. When you're animating through a scene, you don't want Mandelbulb to be changing your far plane. Because what's going to happen is you're going to have a keyframe, you, all right, with a certain far plane, a certain depth, a certain stop rendering after the far plane point, okay? And next keyframe, all of a sudden your far plane is something else. Next keyframe is something else. And so what will happen is the visual that you will get is that you'll have objects in the background that will come in and go back out again, come in as you move through the scene. You don't want that. Well, maybe you do want that, but normally you're not going to want more or less objects in your scene flicking in and out as you move your camera through the scene. You don't want that, typically, unless you do. Now, let me demonstrate how Mandelbulb will change the far plane on you, especially if you're working in an animation. All right, so 448. So what I'm going to do is I'm going to illustrate how this far plane gets changed on you. I'm going to move this to view. All right. Now I'm going to pull it back from the main view back into the navigator with the parameter. Pulled it back. Now my far plane changed from 448 to 316. And that's it. That's how you reproduce Mandelbulb automagically changing the far plane. You move it to main and then you pull it back. And Mandelbulb will change it for you. All right, the best you can do is put it back. Every time it does that, push it back to main. All right, but let's recalculate it. All right, let's see if we can pull the parameter back, pull the scene back to navigator. All right, watch the far plane down here. Let's see what happens. Parameter. Okay, that time it didn't change. All right. Parameter didn't change, parameter didn't change. All right, now let's push it back to main, calculate it. Let's go back over a navigator, pull it back, didn't change. Good. Now, you think you're in pretty good shape? Not necessarily. What I have found is that the far plane may or may not change when you pull it into the navigator, may or may not. Usually it does change when you move you navigate in your scene. All right, let me give you an example. So let's pull it back. Okay, we got 448. Now let's move in the scene. Let's kind of do that. Let's kind of fly through the scene. Maybe what we'll do is we'll slide to the right. Maybe we'll look again. We'll look to the left now. Okay, so you're getting an idea here. So now let's push that back to main. Let's recalculate it. Now you can see here that my camera's in a different position. Now let's pull it back in. And now we are 336.6. We went from 448 to 336 on the far plane simply by moving our camera in the scene. Now, the difference between 448 and 336 may not have a serious visual effect, but it may. It really depends upon your scene. It depends upon how much depth you have in the scene, how much material. The lighting has, I found, has something to do with it. What Mandelbulb is doing here in the navigator, it's trying to be smart. It's trying to adjust things according to perhaps what the developer thought might be useful to the creator, the user of the Mandelbulb application. Not likely. Doesn't work for me. Because when I'm animating and I'm moving through the scene, I do not need that far plane moving all over the place like that. I don't care if it moves a tenth of a point. I don't want it to move at all when I'm animating. When I'm doing a still, I don't care. I'll adjust it, not a big deal. Keyframe, far plane here, keyframe here, and the far plane's moved. I don't want that. So that is a gotcha. And it's a pretty significant gotcha too, all right, from a creative standpoint. Now okay, 333.6. Now let's keep an eye on this far plane here. Now I'm gonna let's say I didn't see that. I'm not paying attention to the far plane. So now, okay, so I get it back from main. Let's move a little bit more. All right. Oh, let's look down. Why not? Okay. 336.3, 333.6. I like that position. I'm going to move that back to main, calculate it. All right. Now let's take it back into the navigator. All right. Now my far plane went from 336.6 to 226.6. This Mandelbulb, every time I move it from main to the navigator, it changes the far plane, as long as I move. If I don't move, let's say I don't move, push it to main, calculate it, pull it back, watch the far plane here. I'm going to pull it back, 226, didn't move. Back to main, calculate, back to navigator, didn't change. So the secret to the sauce is when you move, when you move your camera in the scene, push it to main, calculate it. I'm only calculating it to show you the difference in the scene. Now let's move it back. Watch the far plane. Now let's move it back. All right, now it went to 231.2. I reproduced the problem of the far plane takeover by moving a scene into the navigator, moving changing the position of the camera in the scene, and then moving it back to main. Okay? So the far plane change that is done by the software itself has a reproducible pattern to it. Now, and because it's reproducible, you can better understand how to deal with it. Now, let's talk about that, how to deal with this. A couple ways you can do it. You can keep changing it back to what you wanted. Let's get it right here, 448. Every time it does that, you change it back, and then you push it back to main. All right, every time. You keep fixing it. That's one way to deal with it. The other way to deal with it is to avoid pulling things from main into the navigator and then moving. In other words, don't keep pulling it back from main. Don't bother looking at your scene in main view. Every time you make a new keyframe, don't push it back to main view. Just leave it. Leave it in the navigator. Let me point that out. Let's just let's put 500 in here just to give us a nice round number. All right, I'm going to move. All right, I'm going to make a keyframe. I made a keyframe. I'm going to move again. All right, let's just do other things. Let's look right. Let's slide a little bit here. The far plane is not changing. Okay. All right, I'm going to make a keyframe. All right, I'm going to move again. All right. Let's slide down, whatever. All right, let's make a keyframe. Now, the far plane here didn't change in this particular entry. You notice here that I never moved it back over to main. I stayed in the navigator. I just stayed here. Now let's see whether or not Mandelbulb modified my far plane by me not sending it back to main and pulling it back. We can tell that by looking at our keyframes and pulling them back into the navigator. Now this little button right here will send that keyframe back to main, and then I can pull it over to the navigator. But what's interesting about the Mandelbulb is you don't have to go through main. Watch this. I'm going to send this back to the main, but I'm not going to recalculate it. All right, but what I am going to do is I'm going to do the parameter. All right, so I don't have to recalculate every time. Keyframe, I sent it back to main, but I didn't render it on the screen, but it's still there. So the parameters can still be pulled into the navigator, and it changed. Let's go to keyframe number 2. That's all right. Push that to main, but don't calculate, and then pull the parameters in 430. 417, 417, 430. All right, now let's go to keyframe number 3, pull that in, parameter, now 357. Okay, now there is no way to fix that, that far plane. There is no provision to fix the far plane. The processing's window, right here, all right, does give you the option to be able to modify certain values that are associated with each of these keyframes. All right, for instance, if I wanted to change the DE stop on each of these keyframes, I can do that very easily. But there is no far plane modification in this processing window. The point is that once that far plane is set into that keyframe, that's set into the keyframe. There's nothing you can do about it. All right. Now what you can do is you can push it to the navigator. You can set it back to 500. All right, and now you can push it back into that keyframe. So if I go load that keyframe again, keyframe, parameter is 500, okay? Let's go to this next keyframe, push that to the main, but don't calculate parameter, 430. Now I'm going to change that back to 500. Now I'm going to overwrite that old keyframe. Let's push it back, take a look at it, there's 500. The way you fix this far plane in these keyframes is by loading them back into the navigator, modifying the far plane, and then pushing it back to the keyframe. Can you imagine if you've got 50 or 100 or 200 of these keyframes? You don't want to be doing that. So the whole idea, and the best thing you can do, is to keep an eye on the far plane. I'll give you a for instance here. So, all right. So let's navigate. Let's get this keyframe back into the navigator. Go to the next keyframe. I'm going to move, but okay. I'm looking up. Well, let's move forward a bit. Now, rather than assuming that your far plane is going to be 500, when you make a move, set it to 500, then push the keyframe out. And I can prove that to you. I'm just going to put junk in there. Let's pull this keyframe back. Parameter, there's my 500. All right, so here's how you deal with it. Every time you make a move, if the far plane modification is of concern to you, in other words, you're in a sensitive situation where you really do want a far plane and you want it to stay at whatever value you put, what you have to do is this. Every time you move your scene, before you make a keyframe, you got to get down here and you've got to re-enter your far plane then make a keyframe. All right, let's do it again. Let's move and look over here. Okay, so before I push that down to I got to change that far plane to 500, and I think I need to get I need to get out of the entry field. Just go over here. Okay, push that down. Well, let's go see if my far plane's stuck, and it did. Okay, 0.1, it's stuck. Okay. All right. So the way you deal with this is that if your far plane setting is sensitive to your particular Mandelbulb scene, the best way to avoid problems with it is to, every time you move, to put the far plane back in before you push it to a keyframe. All right, so let's recap. All right, so let's get our view back here. Let's get that back up. Parameter. There's my 500. So once the far plane is set into the keyframe, it will stay in the keyframe. All right. The problem is that you've got Mandelbulb is modifying the far plane on your behalf and never telling you that it modified it. It's trying to do a good job. And if your scene is not sensitive in terms of the depth that you want as the creator, if you want a depth of this, Mandelbulb is magically coming up with different depths based upon some sort of code algorithm deep down inside. You may not want that. On the other hand, it may not bother you. All right, if your scene is not really sensitive to depth, you don't really care if the far plane wanders around a bit. But if you have a very sensitive scene in terms of depth, such as the dazzle here, all right, you've got something really, really close and something kind of midpoint, and then out here, all right, that's a sensitive scene, sensitive to the far plane. All right, if you have a sensitive situation in terms of the depth of your scene, you've got to be careful that far plane doesn't get so out of whack that all of a sudden you're flying. When you go to render your animation, you know, things are flipping in and out as you move through the scene. You don't want that. All right, so let's recap. The far plane is valuable for creative purposes. You don't care if it's trying to conserve any horsepower of your PC. It is a creative tool that can be very, very useful creatively. What happens is that when you navigate, when you modify the position of your camera, the far plane is likely to be modified by the program itself. You can't avoid movement in your scene in an animation. That's the whole point of an animation, is to move through the scene or to modify the scene graphically. All right, so if a very sensitive situation, you got to keep an eye on the far plane and reset it. All right, each time you make a keyframe. Now this is only if your scene is very sensitive to depth. Sometimes you won't even care. Let it have a good time. It doesn't matter. All right? All right. So the far plane takeover. It's a problem where the Mandelbulb software will modify the value of the far plane. Typically, when you move through the scene, once that far plane is set into a keyframe, the only way to fix that, because this processing doesn't have the capability, the only way to fix the far plane in a sensitive situation is for you to pull that keyframe back into the navigator, modify the keyframe value, whatever it might be, and then push it back to the keyframe. All right? All right, so that's it for the Gotcha number one, the far plane takeover, where Mandelbulb will automatically modify the far plane for you, which could be a problem in a scene where the depth is sensitive in terms of creativity. All right, so I hope this helps. Hey, I know this is a long session, but this far plane is actually quite important creatively, and it can really get in your way of making a long animation. Hey, you make an animation with 2, 3, or 5 keyframes, no big deal. But when you're into an animation where it's going to go for 2.5 minutes, such as the dazzle, all right, and all of the properties of your animation are important. When that far plane is getting messed up on you from one keyframe to the next, it can really interfere with your creative objective. All right. So listen, I'm going to put out some more Mandelbulb 3D gotchas in time, and I'll get them up here on this YouTube channel. Take a look, take a listen, see if they're meaningful to you. I'm going to talk about bugs. I'm going to talk about interferences with creativity. I'm going to talk about real crashes where the Mandelbulb application just disappears instantly. Okay? They're coming. I got to record them, but I have a very good idea what I want to cover from my own experiences, and I think you'll enjoy those gotchas as well, and ideally save you time and save you frustration working with the Mandelbulb 3D fractal generator. Okay? So I'll see you in the next gotcha, and we'll explore another issue that's important to all of us creators. Take care.